8.3 and 8.4 are graphing sections, and they're all about graphing the different kinds of rational functions that we'll see. The first one that we're going to talk about in 8.3 is a reciprocal function. So a reciprocal function is most simply put y equals 1 over something times x. The parent of that, it's called a hyperbola. The parent function of it is y equals 1 over x. Now, hyperbola is a different looking graph than probably you've ever dealt with before. It has something called an asymptote, or has actually a couple of asymptotes. Asymptotes are lines that the graph will get close to but never actually touch or cross. And the hyperbola, the parent function, has asymptotes at x equals 0 and y equals 0. When we graph asymptotes, we graph them with dotted lines to represent that we know that they are not actually part of the graph. They are just invisible boundaries that the graph will get close to but never touch or cross. Now, the parent function has a domain and range of all real numbers not equal to 0, because if I were to put 0 in for x, I would get an undefined value for y. So therefore, that cannot be part of the domain or the range. Transformations of these reciprocal functions. So just like all of the other functions that we've seen, they don't just stay in that one spot. They move all around. So the h and the k value are coming back from our previous chapters. H, remember, represents the horizontal translation. K represents the vertical translation. And H, the horizontal translation, also gives me asymptotes. It gives me vertical asymptotes, meaning they go straight up and down. And the equation for the line of the vertical asymptote is x equals h. Now, it's important that you include that x equals part, because if we just list the asymptote at the h value, we don't know that it's a vertical or a horizontal asymptote. So you need to say the x equals part. Similarly, we have k as a vertical translation, so it gives a horizontal translation at y equals k. Just like the vertical asymptote, we need to list the asymptote as y equals the k value and not just the k value. The A value that you see on here just represents the orientation of it and the shape. So it tells how steep or how flat looking the hyperbola is, and it tells whether it's in quadrant 1 and 3 or quadrant 2, 4. If A is less than 0, then the graph gets reflected across the x-axis, so it changes quadrants. It goes down to quadrants 2 and 4 instead of quadrants 1 and 3. So for these 3 graphs, these are all graphs of hyperbolas. We're going to identify the asymptotes, that's the dotted lines. Those are equations, because remember they're lines. And we're going to identify the domain and the range for each of them. So for the first one, it gives me the graph, which you don't have to type in. I've already given you a picture of the graph on here. The asymptotes would be the equations of each of those dotted lines. So there is a vertical line here at -2. And remember, vertical lines have equations of x equals. That's why the vertical asymptote is x equals. Even without this graph, we should be able to pull out that the vertical asymptote is at x equals -2, because we should be able to identify h and k from the given equation here. In this equation, h is always found underneath the fraction, and k is always found being added or subtracted to the fraction. So in this case, the h value, just like in all of the other translations that we've done, h is always the opposite of what it appears to be. So h is -2 and k is 0. That's why this has a vertical asymptote at x equals -2 and y equals 0. Vertical, x equals -2. Horizontal translation is at 0. Then we have to list the domain and range. Your domain and range is all of the x values except for where it would touch the asymptotes. So I have domain, in this case, all real numbers except -2. And this one, all real numbers for the range except y can't equal 0. Taking a look at the next one, let's list our h and our k values and see if they match up with what our graph is. Our h value, it's the opposite of what it appears to be on the bottom. So it's -1, and k is equal to 2. So we should have a vertical asymptote at x equals -1, which we do. And we should have a horizontal asymptote at y equals 2, which we do. Those are our h and our k values. Domain, all real numbers except x can't be -1 because that's an asymptote. Range, all real numbers except y can't be 2 because that's an asymptote. Take a look at C. Here's our equation. We can identify h, we can identify k. H, there's nothing being added or subtracted, that makes it 0. K, there's a 4 being added or subtracted to the fraction. So I have an asymptote at x equals 0 and y equals 4, which is confirmed by our graph here. The domain, all real numbers except for what x can't be, that's the asymptote. And all real numbers except for what y can't be, that's our asymptote. So now that we've got the graphs and we can look at them with the asymptotes, let's take a second to actually graph them on our own and list all the same information, but without being given the graph. Now I know that these are reciprocal functions because they don't have any kind of variable in the top. That's an important distinction because when we get to 8.4, they will have variables in the top. Therefore, their asymptotes and all their rules will be slightly different. So please make sure that you practice tonight with these kind of graphs because you will get a little confused moving into 8.4. And we've got a quiz that's just over graphing that includes both of these kind of functions. So make sure you get sufficient practice with telling the difference between the two. For number 2, for A we have h and k that we've got to list. H in this case is equal to 0 because there's nothing being added or subtracted to the value on the bottom. K is also equal to 0 because there's nothing being added or subtracted to the fraction. That means that my asymptotes are at x equals 0 and k equals 0. Y equals 0. So my domain and my range, before I even graph this, is going to be all real numbers except x can't be 0, and all real numbers except y can't be 0. So let's type that into our calculator. I got a couple of things I got to clear out here. But I have 5 over x. Now your asymptotes are not really going to show up on here. Some of the older version calculators, you might see a line or something like that. It's not really showing the asymptote. It just doesn't know how to separate them out. So you are going to be solely responsible for finding all the asymptotes. So when I graph this, I can see the 2 branches of my hyperbola, but notice I don't see the asymptotes. You still have to graph the asymptotes. That will be part of the points on the quiz, is graphing those asymptotes. So I've got to graph at x equals 0 and y equals 0. Remember, we do that with dotted lines. If you're using a pencil, make sure that your dots are dark enough that I can tell where they're at. If you use a solid line, that indicates that it's part of the graph, and that's not really what's happening. So make sure that you are using dotted lines. Now, to find out what the actual points are on these branches, because you can't just go, oh, I think it's here and here, we need to go to our table and just plot some points that don't look too terrible. Some from each kind of a branch. So we saw a branch in quadrant 1 and we saw a branch in quadrant 3. So that means some where x is positive and some of these where x is negative. You'll notice that when you get an asymptote, you get an error. So you're going to plot those points on there. So take a few moments, take a look at your graph, and plot the points. So I've got one at 0.510, that doesn't show up, but 2 and 2.5. And then we've got one at 4 and 1.25. And we know that the branches are going to go along but never touch or cross our asymptotes. So be very careful that you never actually touch or cross the asymptote when you're drawing them. And if you've drawn in your asymptotes and all of a sudden your lines are touching or crossing, that means that either your asymptotes or your branches are wrong. So make sure you go back and take a look. So the branches are the solid lines because that's actually what's being graphed. And the other dotted lines are our asymptotes. Let's take a look at the next one. First, identify H and K. H is -3. K is 0. So that makes our asymptotes happen at x equals -3 and y equals 0. Our domain becomes all real numbers except -3 and all real numbers except 0, respectively. And we're going to go ahead and plot in our asymptotes. -3 and 0. And then type it into our calculator and see where those branches lie. Quadrant 3 and quadrant 1 and 2 as well, because it's been shifted to the left 3. So let's get some points to be able to plot. So here's that asymptote confirmed at -3. It's an error that makes it an asymptote here. So plotting something before and after that should give you both branches of your graph. So at -3.5, it's at -4. -4, it's at -2. You probably don't have the 0.5s. That's just because I've told my graph to graph by halves. So if you change it back to, go to second and window, you can change it to be halves so that you can get some more points in there, or you can leave it on holes. There's not really a preference there for me. So back to our table, we've got -5 and -1. So here's a place that I'm going to have to be very careful not to actually touch or cross that asymptote. For the other side, I have -2 and 2, -1 and 1, 1 and 0.5. I like to get at least 3 on here just to make sure I've got a nice rounded shape for my hyperbola. Last graph for number 2. Identify your H and your K first. So my H, remember, is found in the bottom, opposite of what it appears to be. So it's 2. K is being added or subtracted, so it's 4. That makes our asymptotes at x equals 2, y equals 4. Domain should be all real numbers except our vertical asymptote. Range, all real numbers except our horizontal asymptote. So you can plot your asymptotes on your graph, type it into your calculator, and get some points. Please make sure, and I didn't mention this before, and I probably should have, that when you type this into your graph, you have to put parentheses around the bottom of your graph, and really ideally the top 2, but the bottom for sure, because we want to tell it to do the x plus 2 all on the bottom, or the x minus 2 all on the bottom, and not just the x. So here's my asymptotes at 2 and at 4. So here's what my graph looks like on my calculator. Go to my table so I can plot some of those points. Now they're not pretty points here. That's okay. Just get as close as you can. You're just trying to get a good shape. Here's your error. That's confirming that my asymptote, my vertical asymptote, is in the correct spot. So at 1, I have at 5, at 0, I'm at 4.5, and -1, 4.3. Be very, very careful. Don't touch or cross your asymptote. On the other side of my vertical asymptote, I have 3, 3, 4 and 3.5, and 5 and 3.66, repeating. Now the reason why these quadrants switch from what we had seen before is because we have this negative value here. The negative for the A value changed the orientation of my hyperbola. Let's take a look at our word problem before we wrap up 8.3. Group of friends plan to get their youth group leader a gift certificate for a day spa, or for a spa. The gift certificate costs $150. C represents the cost for each friend, and F represents the number of friends. So we're going to write an equation to represent the cost to each friend as a function of how many friends it give. So if I take the total cost of the gift certificate and divide it by the number of friends that are going to contribute to this gift certificate, then I get the cost that each friend is going to have to pay. So there's our function. It's a reciprocal function because it's just got one variable on the denominator. So when we graph this function, let's think about what this means for the domain and range. Now, yes, if I just type this graph into my calculator, I'm going to get a hyperbola that has 2 different branches. But do both of those branches make sense? Well, the asymptotes for these are at x equals 0 and y equals 0. So I'm going to have branches that are in the first and the third quadrant. With the first quadrant, everything's positive. But in the third quadrant, I have negative values for the cost and negative value for the number of friends, which doesn't really make sense in this problem. So there's a limitation for the domain and range to this situation. The domain and range are limited to all real numbers that are greater than or equal to 0, because it only makes sense to have positive values for the number of friends and positive values for the amount of money that somebody's going to pay. Now, when you graph this, you may need to change your window just a little bit. If you graph it just on a normal window, you don't end up getting to see the graph at all. And that's because if we think about it, we've got $150 and we're dividing it by the number of friends. Well, 150 divided by 1, if you look at your window, is 150. So at x equals 1, it's all the way up to 150. At x equals 2, it's at 75. It doesn't get down to values that I would see on my graph until well after 10. So we need to change our window so that my y's start at 150. Now that dark line is just because I did not change the scale of my graph. It might make sense to change your scale here to be counting by 10s or 15s or whatever the case is. Then you'll see those little dashes. But now we can see one of the branches of our graph. If you wanted to see the other branch of the graph, you would need to change the minimum to be negative 150. But like we just discussed with domain and range, this branch does not make sense in context of the word problem. This would be a negative amount of friends paying a negative amount of money, and that doesn't really work in our word problem. So we're going to concentrate solely on this first branch. So that means I'm going to probably want each of my values here to count up by maybe 10, because that's what I needed to do on my scale on my calculator. The x values, those can still count by ones, because it would make sense that you might add only one friend at a time. But the amount of money that they're going to pay was going to change by more than that. So I have an asymptote happening because h is 0. I have an asymptote happening at x equals 0. And k is equal to 0, so I have an asymptote happening at y equals 0. Take a look at your table on your graph to be able to pull some points. At 1, it's at 150, which is slightly off our graph. 2 is at 75. 3 is at 50. And you can start to see the shape of our hyperbola. You need to make sure again that we are not going to touch or cross the asymptote.